Hello everyone, and once again welcome back to the final live interaction session of this course, that is the fundamentals of particle and fluid solid processing. Today we will cover the rest of the portion that we have seen in this course. The rest of the portion means apart from whatever we have covered in the first two live interactions, that is we are left with particle size enlargement, transport of fluid solid system, and cutting edge research topic, as well as a very interesting subject that we introduced, the fundamentals of colloids and nanoparticles. Now, in the particle size enlargement, we have seen several interparticle forces, the comparison and the interaction between those forces. We have seen that in order to increase the particle size, what are the steps we have to follow? That is the nucleation and growth of particle. And finally, we have seen a brief overview of some granulation equipment that is typically utilized in the relevant industry. In transport of fluid solid systems, we have gone through the hydraulic and pneumatic transport. We have seen different regimes, the flow regimes, and we have discussed couple of rheological models. The reason is that this type of system basically exhibit non-Newtonian behavior. So, we have seen power law behavior and Bingham fluid. Also, we have discussed several times regarding the shear thinning mechanism. Now, coming to the last segment that we covered, or the last chapter that we covered, was the basics of colloids and nanoparticles. Why these are important, what the fundamental forces that makes this subject more interesting and sometimes complicated. We have seen that interplay between different interparticle interactions. When one dominates, what happens when the other dominates, how the property of the particle changes. In particular, we have seen a couple of applications related to that force interactions, mainly to the suspension of these particles, and when these nanoparticles. So, basically this colloidal suspension or emulsions are unstable. So, the range of the or the time limit of this instability we have explored in this last segment. So, if I go quickly with this overview. So, we started this section by linking with the comminution equipment or the size reducing equipment, which are the terms we typically used. What are the material property that is essential to consider when we consider the size reduction mechanism? What is the milling circuit, that means how this size reduction operation happens, and then we introduce this size enlargement techniques, that in addition to the size reduction, size enlargement is also essential in several industries, and say particularly in the pharmaceutical or the agricultural or the food industry, and sometimes also minerals and metallurgical as well as ceramic industries. So, it basically helps us to control the active ingredients, the control over the surface to volume ratio, the reduction of dust hazard, caking and lump formation. These are we benefit from this size enlargement process. So, there are steps, as I mentioned. What are those steps? We initially agglomerate. This agglomeration by agitation method is called the granulation, that we have seen, and we have seen the brief overview of industrial granulation equipment and the steps in granulations. The steps that we have seen the wetting, growth, consolidation, and finally the attrition when it moves or at the final stage. Because initially, say the concept is basically we have several fine particles, those are weighted so that it can coalesce, its size grows, the growth stage, then it is consolidated, several say intermediate size particles or the granules then consolidates to form a bigger size particle. But then when there are multiple bigger size particles due to their movement or this say when it is in the granulator due to the vigorous movement, the final size of the product dictated by this consolidation and the attrition. So, there will be say the particle wall attrition, particle attrition, and finally the breakage stage, that is the point. So, this interplay between the breakage and the consolidation dictates the final product size. So, before we introduced these steps, we have seen the overview of different interparticle or intermolecular forces that is actually causes these particle interactions, say attractions or the repulsions. So, we have seen van der Waals, the forces due to liquid breezes, different state during this waiting period, that is the pendular, funicular, capillary and droplet. We have seen electrostatic forces, solid breezes, comparison and interaction between these forces, this interparticle forces, in which particle diameter range which one dominates, we have come across that stage, and then we have gone into the details of the granulation, that what affects or what influences this wetting stage, how do we measure the wetting time or the penetration time, droplet penetration time, what is the droplet controlled nucleation regime. There are different types of, mainly two different types of regime. One is that droplet controlled, the other one is the mechanical dispersion regime. There is an intermediate regime. This flow diagram or the phase diagram we have seen, and what causes this, in which regime, which physical property or the which forces are important, we have gone through that. We have also seen the consolidation stage, the growth stage, the competing mechanism between the growth stage and the breakage that leads to, as I mentioned, the final product, and couple of granulation equipment or the granulator, mainly three, that is by its operation, that is the tumbling, mixture and the fluidized, where we have the higher granule density that we can understand from this table, and accordingly its typical application in different industry. A very brief the preliminary overview of how this granulator works, we have gone through those details. And then in the penultimate segment we reached the slurry and the pneumatic transport, the transport of fluid solid system. So, when the fluid is liquid, it is the slurry, and when the fluid is in gas, it is the pneumatic transport. So, how to, first of all, in this case we have seen how to calculate or how to estimate the mixture density of a slurry. What is Einstein equation? Related to that, how to calculate the effective viscosity or the mixture viscosity, what are the flow conditions that can happen when that is the x axis is the superficial slurry velocity and the y axis is the pressure gradient, the saltation regime. So, different types of flow conditions, or in other words we can say these are the regimes. So, we have, say, when these are say when these are a simple non-settling slurry, we have the laminar and the turbulent part. But when these are settling slurry, we have different flow regimes, that is starting from the saltation, heterogeneous and the homogeneous slurry. So, as we increase the superficial slurry velocity, we goes from saltation to homogeneous slurry. Now, so in this case, then we have gone through different rheological models. What are the rheological models that we have followed? That are mainly, as I mentioned, are Power law and the Bingham fluid. But there are several other models, but as a basic introduction to this subject, we have considered only Power law and the Bingham in this case. So, how the slurry moves when these are shear thinning or the shear thickening, how to calculate the del P, because that is essential to drive that flow through a pipeline network, because essentially this transport is essential when we have sufficient solid particles suspended in liquid and we try to transport the solid particles from one place to others. So, essentially we want to know what is the required pressure drop or what is the mechanical pressure drop that is required to drive that fluid from or the slurry from one place to the other. So, we have seen what happens in laminar case, what happens in turbulent case. We have as I mentioned the Bingham fluid, particularly in the yield stress model. We have gone through this Bingham fluid. We have also seen a bit of Herschel-Bulkley, but when the power law index is 1, Herschel-Bulkley becomes the Bingham plastic or the Bingham fluid. So, Bingham plastic rheology in laminar, in turbulent, we have gone through these details. What is heterogeneous slurry? We have seen this concept. In a slurry transport mechanism, what are the steps that are followed, that we have also seen, and also we have briefly gone through the details or the selection of pump that is required in order to pump that fluid. Then we went to the pneumatic transport. As I mentioned, when the fluid was gas or the air mainly, it is the pneumatic transport. What is dilute phase and what is the dense phase, both we have covered, we have seen. In this case, analogous to the saltation and the homogeneous cases, here we had choking point or the choking velocity in the pneumatic transport. So, choking velocity we talk about for the vertical transport and saltation velocity in case of horizontal transport. So, what is the minimum velocity that is required in order to avoid those points? We have seen in details. We have seen how to estimate the pressure drop. In such cases, a generic expression for the pressure drop, and from there based on different assumptions we can reduce the terms in that equations and get what is the pressure that is required to drive that gas solid mixture to flow from one point to the other. The utility of bend, or say this kind of a blind T kind of a bend, and how it impacts the flow mechanism, and in case of dilute phase transport, what are the steps involved, like in slurry transport mechanism we have seen the details. Also we have seen the dense phase transport, and in the final segment we saw the introduction to the colloids and the nanoparticles. Why these are important? Its utility, why it is different from say when we talk about fine particles, and what is so specific about the colloids and the nanoparticles. Again in this case the main thing that is important or it is involved is the Brownian motion, because of its very small size. Different surface forces that becomes dominant in this case, how to estimate the surface forces, what is a van der Waals force, what is EDL or the electric double layer, what are the forces, and which one is the competing mechanism, and by which that competing mechanism what happens, what is Debye length. Then we have seen other surface forces like the absorbing polymer or the bridging and the steric forces. and the net interaction force, that is the famous DLVO theory, the impact of surface force on the fine particles, and then we have seen the suspension rheology. In the suspension rheology, we have mainly focused on estimating its density, viscosity, and we have understood that why shear thinning or shear thickening mechanism triggers and when the onset of this trigger. So, we have seen such phase diagram, and we have discussed this. When this is in the y axis, we have the suspension viscosity, and this is the shear rate. So, we have low shear rate the Newtonian plateau, and then the shear thinning regime, and then the shear thickening regime. So, ideally any suspension can behave in this manner, non-Newtonian or even provided we can exert enough shear stress or the shear rate. The influence of repulsive force on these fine particles, based on that we solved one problem, and then we concluded this course. So, today, as I mentioned, we cover now any question, any query that you have in these 3 chapters. In the colloid or the nanoparticle sections, we have seen its sedimentation rate or sedimentation time, when it can sediment, or what is the time limit or the time range that it becomes unstable. With that, we concluded this whole course. So, I hope you enjoyed this course, and if you have any query, any question till this part, or say on these 3 sections specifically, I am looking forward to your questions if you have any. Otherwise, it is not the end of our interaction. Today is the last live interaction, that is for sure, but you can always post your questions in the forum. I will answer, or the TAs will answer those. We will try to resolve those queries. So, with that, since I guess there is no questions, I conclude this session today, and I hope again you have learned the basics of this subject. You will find its advanced stages in your forthcoming curriculum, which I hope will this course will make a foundation for those interesting subjects. So, once again, thank you for listening to my lectures, enrolling to the subject, taking the exams, who are taking the exams, and I hope that this would serve that whatever the purpose for which you have taken this course. And finally, thank you for your attention. Happy Diwali to all of you. Thank you.